Hi, today I am going to discuss about computer network. So generally the arrangements of different computers, the arrangements of different computers, different hosts, different systems in our network is called computer networks, or the networks of network is called computer network. Suppose these are hosts A, B, C and D. So in computer network, these all computers are going to interact with each other, how they are going to communicate with each other, which protocol they are going to use, which IP addresses they are going to use. This all comes in this course. Okay, we all these things we are going to see one by one, but before going to see, I want to introduce some number system. So initial number system is unary number system. The base of this system is 0, and if we want to represent any number, for example, if we want to represent 1, then use 1 0. If we want to represent 2, then use 2 0. If we want to represent 3, then use 3 0. So on. Okay. This is nothing but unary number system. Next thing is binary number system. Binary. The base of this system is 2, and the number come within this number system is only 0 and 1, which means when we are working with binary number system, then we use only 0 and 1. Okay. So how to represent any number in binary number system? The best way and the easiest way is this. Write this number of sequence: 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, which means 2 to the power 3 means 8, 2 to the power 2 means 4, 2 to the power 1 means 2, 2 to the power 0 means 1. Okay, this sequence is important. And if we want to represent 5, then add 4 plus 1 is 5, only one way. 4 plus 1 is 5. These 2 bits are 1, remaining bits are 0. If we want to represent 7, 4 plus 2 plus 1 is 7. This bit is 0 and these 3 bits are 1. If we want to represent 9, then 8 plus 1 is 9. This and this bit is 0, remaining bit is 0. If we want to represent 12, 8 plus 4 is 12. Then these 2 bits are 1, remaining bits are 0. So like this we represent any number system. And moreover, remember these points: 2 to the power 10 means 1024, which is also called K. 2 to the power 20 means mega, 2 to the power 30 means giga, and 2 to the power 40 means tega. Okay, these all are important. So how to represent any number? Okay, we can go beyond this. Okay, 2 to the power 4, 2 to the power 5. Suppose if we want to represent 41, big number. Okay, 2 to the power 4 means 16, 2 to the power 5 means 32. So how to get 41? First add 32 plus 8, 40, and plus 1, 41. So this bit 1, this bit 0, this bit 1, these 2 bits are 0 and this bit 1. This is the representation of 41. Easy. Okay. Now see this. If there is a sequence of numbers of 1 bit, or 2 bits, or 3 bits, careful here. If there is one bit, then I have no choice to choose. We fill this bit with either 0 or either 1. Okay. If there is 2 bits, then I have choice to choose one bit. Okay. I have choice to choose one bit. So how to fill these 2 bits? 0 0 0 1 1 1 1 0. So if I choose one bit, then entire number space is divided into 2 parts, which is nothing but 2 to the power 1 parts. Okay. How? In chosen bit, either we choose 0 or 1. In chosen bit, either we choose 0 or 1. If there is 3 bits, so how to fill these numbers? All first bit, all 4 0, all 4 1s. So with 3 bits, how to form? How many numbers we are going to form? 3 bits, 2 to the power 3 numbers, which means 8 sequence. Okay. And in second bit, 2 0 2 1, 2 0 2 1. In third bit, 1 0 1 1 0 1 1 1 0 1 1 1 0 1 1. Okay. So through this, fill this. Okay. So out of 3 bits, if I choose 2 bits, then entire number space is going to divide into 4 parts. How? In chosen bit, either we choose 0 0 0 1 1 0 or 1 1. Okay. In chosen bits. So which is nothing but 2 to the power 2 parts. So on, if I choose 3 bits, then 2 to the power 3 parts. If I choose 4 bits, then 2 to the power 4 parts. Okay. So in general, if there is a number of n bits, and if I choose k bits, then remaining bits is n minus k. So if I choose k bit, then entire number space is divided into 2 to the power k parts, right? How? If I choose 1 bit, then 2 to the power 1 parts. If I choose 2 bits, then 2 to the power 2 parts. Similarly, if I choose k bits, then 2 to the power k parts. So coming to computer network, this n bit is nothing but our IP address. This k bits is nothing but chosen k bits. Points to be remembered, chosen k bits is nothing but our network ID. And this remaining n minus k bits is nothing but our host ID. So in our computer network, IP address is of 32 bits, version 4 only. Okay, 32 bits. And these chosen k bits, how to choose, how many bits we are going to choose, and how many bits remaining for the host ID, these all comes into classes of IP. Classes of IP we are going to see next. So remember, our IP address of 32 bits, and these 32 bits are going to divide into 2 parts. One part is of network ID and one part is of host ID. How many bits are going to use for network ID, how many bits are using for host ID, depends on classes of IP. Different types of classes, A, B, C, D, E. 5 types of classes of IP. We shall see one by one. Okay.